All right, just take a look at this thing. So here it is, drift speed, right? We're going to be using these formulas, right? So I is n area drift speed times charge, right? And n is what the charge density, right? The density of the electron. So that's going to be our n, right? Okay. Now notice that it's in centimeters, right? So we need to do our stuff in centimeters. Okay, so just be very careful with that. Notice that they're giving us resistivity in ohm meters. And so this is somewhat problematic, right? Okay. And then we're also going to use the resistivity is the resistance times the area over the length, right? So this looks like a rho, looks like a density symbol, but it's not. Okay. So the first thing says calculate the resistance of the conductor. Well, R is just going to be resistivity times the length divided by the area, right? So the resistivity is, let's see, what do we have? Oh, the length, the dimensions. Okay, so 10 centimeters, right? So you're going to make this 0.1 meters, right? And then that'll be your length. Our area is going to be 0.02 centimeters, so 0.02 times 10 to the minus 2 by 0.02 times 10 to the minus 2, right? And I'm doing that because they're giving you centimeters. So centi just means times 10 to the minus 2. We've got to do our stuff in meters, right? So, and then our resistivity is this. So plug that in and you should be good. You will get that it's much less than 1 ohm, right? Less than 1/10 of an ohm. More than 100th of an ohm, though. Okay? Then it says calculate the drift speed of the electrons in the conductor in centimeters per second. Right? Well, this gave me a rash, but I think I did it in centimeters. Okay? So we're going to use this guy, right? So if we solve that for V, V is going to be the current divided by the area times the charge density of carriers, right, times Q, right? And so V is going to be I over the charge density. So that's this guy here, right? And I did it in centimeters, so I stuck that right in there. Current can be just, that's fine, whatever that current is. Do they tell us the current? They must. Oh, 2 amps. The meter reads 2 amps, right? So that's our current. Okay, and then our area is going to be, remember we're doing this in centimeters, so it's going to be 0.02 times 0.02. I'm keeping everything in centimeters. I'm hoping this works, right? Okay, and then I think that works, right? Because notice that this thing is given per cubic centimeter. Really, it should be so many per cubic meter. They gave it per cubic centimeters, which I wish they wouldn't do. It's kind of confusing, I feel like, right? So when we do this, notice that this has got the units of centimeters to the minus third, right? So 1 over centimeters. This has got units of centimeters, right? So centimeters times centimeters times centimeters to the minus 3, right? This is going to have units of centimeters per second, right? Because that'll be coulombs per second, et cetera, okay? And then let's see, we want Q, and Q is the charge of an electron, right? I can't think of a situation where we use this formula and Q just wouldn't be 1.602 times 10 to the minus 19th. Honestly, I think it's always that, right? Because this thing literally is electron drift speed, so that would be the Q, okay? So again, the current is going to be, what, 2 amps? N is going to be this, and that's in centimeters, but that's okay. We're going to do centimeters there, and then we'll end up with centimeters per second, okay? Because this is coulombs per second. All that's left standing is just centimeters per second, okay? I found that annoying. By the way, it is somewhere between 0 and 1 centimeter per second. It's close to 0.4 centimeters per second. All right, are we ready for the exciting next page? Okay. The The electric field inside the sample can be approximated as a uniform electric field between the two parallel plates, right? So what they're saying is that as it flows through this thing, right, okay, that this is one side of the parallel plate, and that's the other side of the parallel plate. And they're trying to get us to use this V is E times D or something like that, or E field is V divided by D, right? We've done this before. Okay, so let's take a look at this guy here, right? The electric field is going to be the voltage, and in our thing it was like minus the V over the change in R or something like that, right? This is a formula from field theory, right? The change in distance is the length of the wire, right? So that's 0.1. And then the voltage you have to figure out, right? How do we figure it out? Well, V is IR. Didn't you figure out the resistance in the previous problem? Right? You figured that out in part A, right? From part A. Okay, the current is given to you as 2 amps, right? Is that right? So you're going to go 2 amps times that, whatever that resistance is, and get the voltage. You're going to plug that voltage in for that, divided by 0.1, and you will get the field strength, which is close to 1, closer to 1 than 0. I'm just going to say. And then they say, show that V over E is 1 over nope. It's like, there we go. How are we going to do that? Well, let's see. Let's start with this guy. We know that I is equal to N A V times Q, right? And then Q is E, right? Like the charge of the charge carriers is E, right? So I, we're going to plug in an E for that, right? So I equals N A V times E. It's Nave. All right. I knew her well. Okay, and then remember that E is going to be the change in voltage over R, right? We have this formula for that. So what's that going to look like? Well, that's going to be V over the length of the wire, right? Right? Yeah. The wire's got a length that we think about it as like, I know this is a terrible picture, I'm so sorry. Right, this is our L, is this, right? Okay, and then isn't that going to be, can't we make that IR over L? Yeah. Oh, that's fun. Oh, we need to get resistivity in there too. Okay. So, so we've got, here's what we got so far. We got I equals, I've got that E is equal to IR over L, right? And then what can we solve? What can we substitute in for R? R is, let's figure this out. Okay, hold on. I'm going to get you an answer here. So rho is RA over L, right? So that means that R is rho, that's the resistivity, right? We know that. Rho times the length over the area, right? So I'm going to say R equals rho length over area. Now, how are you going to show that this is the case? I think what you're going to do, what happens? Can you stuff this in for that? Can you stuff that in for this? I feel like you could, right? I feel like you could do that. And then just mess around with it. Get the V over on the left side on top of the E, right? And then, just go crazy, okay? Just show them what you can do. Wow, I love that. Do you like that? I don't know. I think these are sort of tricky. Okay, I think I'm done here.